Hey, y'all, let's cover 1.5. Don't forget to read the section. I'm going over most of it for you, but as you go through, make sure you take any notes. And if there's any questions you have, let's discuss it before class or during office hours or after class. I'm good with any of those. Okay, so we're going to factoring the greatest common factor, and that just means we're going to pull out whatever all the terms have in common. So we're looking at each of these terms and what do they have in common. We want to pull out the largest information that we can. I can see that 6 doesn't go into these, but 3 does. So 3 goes into 6, 45, and 21. So 3 can be pulled out, and whenever I'm left with 3 from 6 is 2, 3 from 45 is 15, and 3 from 21 is 7. Okay. Now we're going to look at the x's. We've got x cubed, x squared, and x. The largest one we can pull out is x because that's what they all have in common. When we pull x out from the first term, we're left with just x squared. The second term would be an x, and the third term, it's already been removed. Finally, let's look at our y's. Y cubed, y squared, and y. So we can pull out a y. We're left with y squared and y, and that is our final answer for this. Okay. Greatest common factor. Next one. Factoring a trinomial with leading coefficient of 1. These are delightful. Trinomial with the form can be written and factored as, okay, it's just showing you how to actually do this. And it says, can every trinomial be factored as a product of binomials? Well, in class, I showed you x squared plus 2x plus 2. And just to prove, if they say that it can be, the question is there something that can't? So that's my goal, is always to find something that cannot be factored. We have to use plus since they're both plus. X squared breaks down to x and x. 2 only breaks down to 2 and 1. So these are our only options here. Hold on. Oh, okay. So it's taking this trinomial here and seeing if we can actually factor it. And when we check this, I get x squared plus 2x plus x plus 2, which ends up being x squared plus 3x plus 2. So these are not equal. This is a prime, and it cannot be factored utilizing 2 binomials. Okay, so the answer is, can every trinomial be factored as a product of binomials? No, they cannot. Not all of them can. Those that cannot are considered prime. All right. Factoring a trinomial with leading coefficient of 1. And that's just breaking them down into 2 parentheses. Looking at the first term, x squared breaks down to x and x. When you FOIL, when you multiply x times x, you're going to get x squared. And then the last 2 terms are going to be made up of either 15 and 1 or 5 and 3. That's what 15 breaks down to. Okay. I need to find which one of these 2 sets will give me a 2. I can subtract 15 and 1 and get 14. That's not going to work for me. So it has to be 5 and 3. And the other thing I see here is it's a positive 2x in the middle, which means our largest term, when we multiply the OI, the outer and inner for FOIL, we get 5x and 3x. We want that 5x to be positive and the 3x to be negative in order to have the middle term being 5x. So the final answer is x plus 5, x minus 3. Okay. Does the order of the factors matter? Does it need to be x plus 5, x minus 3, period? Or can it be x minus 3, x plus 5? Doesn't matter. Okay. All right. Factoring a trinomial by grouping. So for this one, we're just going to break 5x squared plus 7x minus 6 into 2 parentheses. 5 only breaks down into 5 and 1. Don't forget our x's here. So then the next thing I look at is the 6's can be 6 and 1 or 3 and 2. The way I did this growing up is it's just trial and error. In class, I know I put 3 and 2 here and 2 and 3 here. That's just to check myself to see which one's going to work. The way this would look in a different light would be 5x. I would try each one of these darn things. So I would have a 6, a 1, a 1, a 6, a 3, a 2, a 2, a 3, and I would check each one of these to see what's going to work. I would start off with the 3s and the 2s first to see. So then this is whenever I go through and I do the OI again as well. I know my first term is going to be 5x squared. I got that set. I know my last term is going to be 6. I got that set. So the next thing I need to look at is what's going to give me that 7. Okay, so I'm going to go 3 times 1 is 3x. 5 times 2 is 10x. That right there gives, when these are subtracted, will give me my 7x. Okay, so this has to be a 3. And this has to be a 2. Now, we had a student in class show us another way to do it. If you're comfortable with that, freaking do it. Move on. That is great. I'm going to stay consistent with how I do this, just trial and error. So I need my larger number. The 10 needs to be positive since my middle term is positive. So I need my 10 to be positive and my 3 to be negative. So my 3 has to be negative. My 10 has to be positive. So my final answer is 5x minus 3 and x plus 2. Now I could have gone through and checked other numbers. 6 times x is 6x. 5 times 1 is 5x. That's not going to give me a 7. I can go 1 times x is 1x. 5 times 6, ooh, that's 30. That's not going to get me there. And then 2 times x is 2x. 3 times 5 is 15. Again, that's not going to get me a 7 either. Okay. All right, let's look at perfect square trinomials. The perfect square trinomial can be written as a square of binomials. Factoring a perfect square trinomial is just taking the square root of the first, square root of the last, and the sign of the middle. And that's the way I always think of it. So square root of first, square root of last, sign of middle term. Okay. So for this one here, square root of the first is going to be 5x. Square root of the last is going to be 2. And the sign in the middle is positive. Don't forget your square sign. Boom, done. Okay. But how do you know that that's what it actually comes out to? Unless they tell you. Well, let's break it down. 25 is 5x and 5x. 4 is 2 and 2. And then positive and positive, check it. 5 times 2 is 10. 5 times 2 is 10. 10 plus 10 is 20. So this shows us the perfect square as well. Okay, let's look at the next one. This is the difference of squares. So for difference of squares, we can break this down into 2 parentheses. 9x breaks down to 3x and 3x. 25 breaks down into 5 and 5. And then since the sign's negative, you're going to have a negative and a positive. And that's it. Difference of squares. Now, is there a formula for the sum of squares? There is not. Because if you have, let's use the 3x. 3x plus 5 and 3x plus 5. Yes, that's 3x plus 5 squared. Oh, they're wanting to go the other direction. So they're wanting 9x squared plus 25. Well, if we did that, 3x, 3x, 5, 5, they'd have to both be positive since it's positive. And that would give us 15x and 15x. So no, we're not going to end up with this in the end. We're going to end up with 9x squared plus 30x plus 25. And that's not equal, so it doesn't work. All right, last page for 1.5. And yes, I'm going fast through this because I've already lectured on it in class, and you can pause and rewind. Good stuff. So we can factor the sum of 2 cubes by using these 2 formulas. Please ensure that you have these in your notes so that when you're doing your homework, you can follow along. I'm just going to start with the factoring the sum of 2 cubes. So the way you need to do this is you need to find out what the cube of 512 is. All right, so on my calculator, I'm just going to put 512, and I showed you this back in 1.3. I'm going to take 512, raise it to the power of 1 divided by 3. So open parenthesis, 1 divided by 3, close parenthesis, equals, and it's 8. So what this looks like, to make it look like this here, is x cubed plus 8 cubed. Rewrite it like that, and it will make it easier for you to fill in the rest of this, because all you have to do is just copy it just like it is. So A is x, B is 8, so that's x plus 8. And then for the trinomial, you square the x, and you square the last one. That's why I always think of it this way. And then the sign has to be negative on this one, since this sign is positive. Right there, see, it's negative. And then the last thing you do is multiply these two terms together. That is the answer for factoring x cubed plus 512. Now for the factoring the difference of cubes, I'm going to do the same thing. I'm going to take the 8x cubed minus 125 and break that down into my cubes. The cube root of 8 is 2, and then x, and that's cubed, minus 5 cubed is what that looks like. So there's my A, there's my B. Come up here, you've got A cubed minus B cubed is equal to A minus B. I'm going to keep this where you can see it. So 2x minus 5 times, take the A and square it. 2x squared is 4x squared. And then for the B squared is 25. All of these have to be positive in your trinomial when you're dealing with the difference of cubes. Okay. And then the middle two terms are multiplied, or just the multiplication of the 2x and the 5, which is 10x. And there is our answer for the difference of cubes. Again, write down any questions you have. Let's discuss them before, after class, or during my office hours. Message me also. Either way, whatever you need to do. Let me know if you need help.